Alright, Math 3, let's practice some multiplying and dividing of rational expressions. So, remember, the main thing here is that we're looking to multiply and simplify. And if it's a division one, then all we have to do is flip the second fraction to get its reciprocal and we can multiply. Now, when we're dealing with these ones that are multiplying, okay, you may think that first you have to multiply. So I'd go 2 times 5 to get 10b on top. 4 times 10 would give me 40. Then I would say, oh, 10 is like 2 times 5, and 40 is like 8 times 5, or 10 times 4. Okay? And so notice we'd basically just be breaking it back down to what it is. So instead of doing, a couple extra turns, what I would just do, because with multiplication, right, of fractions, we just multiply across the top and the bottom. So what I like to do is just to make that fraction 1 and then think of it this way. So then we can just kind of see what we've got. And I can see, okay, 10 is like 2 times 5, so that would eliminate those, which eliminates our 10, so we're left over with b over 4. Okay? And that's what I like to do when it's multiplication, is just draw the line here and make sure I'm looking to multiply those pieces. Then I try to see what I can eliminate. So 8, well, that's like 2 times 4. 10 is 2 times 5, so the 2's can cancel. So I've got 5x times 3x, so we'd have 15x squared on the bottom. Then we got rid of the 8, so 4 and 7 would give us 28 on top. And that's our simplified, multiplied fractions. Okay, number 3, it's multiply again, so we do the same thing. And then I see I've got 3 x's on top and bottom, so I can eliminate one set of the 3 x's. I've got 7 and 7, and 6 and 5. I don't notice anything I can do with that, so I just go 7 times 7, and 6 times 5, x cubed. And that's my answer. Okay, number 4, now it's a division, so first I have to multiply by the reciprocal. And you always change the second one. That's just the rule for it, is that you always change the second one and find its reciprocal, which is just flipping the fraction. Then we can combine and start eliminating things. So 7 on top, 7 on bottom, left with 2 on top, 9 and an a on bottom. Okay? So you can't try to eliminate before you flip it, you have to flip it first. Alright, number 5, same thing. So 8 over 3 times 5 over 5x squared, because we flipped it. 5's cancel, so I'm left with 8 over 3x squared. Can't simplify that further, so that's all I have. And that's basically what we're doing. So, like on number 6, you may want to try to take this 3 and eliminate it from that 9, but we can't because we have to flip it first. So I'd have 3p squared over 6 times 9p over 3. So if I look at this one, now what I can do before I flip it is I could try to simplify the fractions separately if I wanted to. Like 6 is really 2 times 3. So that'll get rid of 1 3. And we're left with p squared over 2. And 9, that's like 3 times 3. So that would get rid of another 3, and we just have 3r. Or 3p, not r. So I'd get 3p cubed, because p squared times p is p cubed, over 2. Alright, now, if we keep going, we can see that they're getting more complex, but it's still the same thing. And notice that these ones are already factored out. Okay, so basically they're all going to be multiplied here. Okay, use parentheses if you need to. So I've got x minus 1s I can cancel, a 7 and a 7 I can cancel. We're left with 4 over x plus 7. Okay, on the next one, same idea, just treat them as if they're all being multiplied together. So n minus 7, n minus 7, n plus 6s, and then we've got a 6 times n plus 8 over n plus 7. Now I suppose if you really wanted to, you could distribute that 6 and get 6n plus 48 over n plus 7, but basically they're the same thing. So you can just leave it like this. So, once again, it's multiplied, so it's kind of like you just are multiplying everything. X minus 10s, x minus 1, x minus 1, 4s. Nothing on the bottom, so it's like a 1, or we can just get rid of that, and we end up with x plus 5. Okay. Now, number 10, you may want to try to start eliminating things across already, but you can't do that yet. You can, however, if they're on the same fraction, you could start doing some elimination there. Like I could start out and eliminate this, then I'd have 1 over x minus 1, and eliminate those, then I just have 4 over x minus 1. Then we flip it, and we'd get 4 over x minus 1 times x minus 1 over 1. Then the x minus 1's cancel, and we've got 4 over 1, or just 4. So, you just got to be careful that you're not eliminating things too soon. Okay. Now, number 11, we've got division here, but these x plus 8s can be eliminated. So we've got 3 minus x over x minus 3 times, this goes on top, x plus 3 over 3x squared. Okay. So, that's pretty much all we can do on this one, so we'll just combine them. And you can just leave it like this, or you could multiply them out and get 3 times x, which would be 3x plus 9 minus x squared minus 3x, so those would cancel. So negative x squared plus 9 on top over 3x cubed minus 9x squared. And you could go with that one. Or you could just leave it in that factored form. And that's fine too. Okay, number 12. Another division one here. So, if there's anything you can eliminate, you can do that first. But there's not, so we've got to flip that. And by eliminate, I mean just on the same fractions. So I was looking at just this fraction or just this fraction. So we get b minus 8 times b minus 9 over b minus 1 times 6b squared over 8 minus b and b minus 9. So b minus 9 we can eliminate. Okay, give myself some more space. So I'm left with b minus 8 over b minus 1 on the left side, but we are multiplying, so can make it just one big fraction, 6b squared. Then this 8 minus b, 8 is like negative 1 times negative 8. Negative b is like negative 1 times b. So if I pull out a negative 1, I'd be left with a b minus an 8. So I could eliminate those, and then it would just be negative 6b squared over b minus 1. Alright. So, on to 13. So we're multiplying here, so I just multiply. 10x squareds can cancel. Then I can factor that one further, right? Because 10x and 30, negative 30, that's like negative 1 times 3 times 10. So I could pull out a 10, and the top would be 10 times x minus 10 over, and this 10 is still left over. So those 10's cancel, and I'm left with x minus 10. Okay, 14. Just be like I'm multiplying it. V plus 9 can be canceled out. A 9v and a 9. That's like 1 times v times 9 and 1 times 9. So a 9 can be pulled out. So on the top you'd have 9 times v plus 1 over v plus 1. Cancel out the v plus 1's, and you're left with 9 for your answer. Alright, so let's just keep going. Now these ones we're going to have to factor first. So, need to factor that a squared minus 9a minus 10. Okay, so if we do box method here, got a squared, negative 10, factors of negative 10 that would add up to a negative 9. Well, we've got 2 and 5, which, if 1's negative, that's not going to be a negative 9. We've got 1 and 10, which if we do a 10, that'll get us a negative 9. So 1a, negative 9a, or negative 10a. I didn't make my box big enough, did I? So a squared, which we know is a times a, negative 9, oh my goodness, what am I doing? Negative 10, which we know is negative 1, negative 10 times positive 1, and 1a, negative 10a. So we pull out the 1, that's positive, pull out an a, pull out a negative 10, and pull out an a. So that one really is a minus 10 times a plus 1. And then that top up there is just 1, so times 1, which really doesn't do a whole lot. Then we have a minus 8 times a minus 10. So the a minus 10's cancel, and we're left with a plus 1 over a minus 8. Okay, number 16. So I need to factor that. Also need to factor that. So 3n, 3 times n, 24, we can do 3 times 8. So if I pull out a 3, I get 1 over 3 times n plus 8, because n is left over, and a positive 8 is left over. It's being multiplied by this guy over 5. So we've got an n squared, negative 80, factors of negative 80 that would be add up to negative 2. Well, a 10 and an 8, and if the 10's negative, add them together, we'll get negative 2. So negative 10 and 8 are the factors. So an n and an n, an 8 and an 8, and it's positive, and an n, negative 10 and a negative 10. So I get n plus 8 times n minus 10. So then I see n plus 8's cancel, times across, we get n minus 10 on the top, times across, 5 and 3, give us 15, and there's our answer. Okay, and that's just kind of what we keep doing. Now with the division, we're going to flip this. Okay, so let's factor that. So a 54, a squared, negative 15. So factors of 54 that will equal negative 15. So it's a positive 54, so I know they're both going to be negative. So that could be 2 and 27 18, 6, and 9. And there we go. So, negative 6, negative 9 A's. So we'll pull out an A, we'll pull out a negative 9, the second A, and the negative 6. So we'd end up with, on the top here, A minus 9 times A minus 6 over A plus 7. Then we flip that so that it would be times 8A squared over an AA cubed and a negative 72A squared. So 3A's and 2A's, so I can pull out 2A's, so A squared, and then 8, and then 72 would be 8 and negative 9. So I would get an 8 pulled out too, and then it would be an A minus 9 left over. So these 8's cancel, A minus 9 cancel, and I'm left with my answer of A minus 6 over A plus 7. Alright, number 18. Okay, a little bit easier. So 1 over x plus 8 times, on the bottom we put 5. I can factor out a 3, and I would have an x left over, and add a 24 and 8. This would be 3 times x plus 8. X plus 8 would cancel, multiply across, and we get 3/5. Alright, 19, same idea. If I pull a 7 out here, I'm left with m plus 8. Okay, so then I get 3 over m plus 8 times the reciprocal, 7 times m plus 8 over 3. 3's cancel, m plus 8's cancel, 7 over 1, which is just 7. Multiply and get the reciprocal, so x minus 10 over 7x times something over x minus 10. Now 5 and 20. 20 is 5 times 4, so we can pull a 5 out and get x plus 4 left over. Not that I think that'll help us. The x minus 10's cancel, but the other ones don't, so you can leave it either way, just over 7x. So sometimes the factoring doesn't really help you, but most of the time it does in these problems. Kind of set up that way. Okay, 21. So we need to factor that bottom here, so we'd have 5 over something. So 72, a b squared. Factors of 72 that are making up negative 17. Well, 8 and 9 are, which, if they're both negative, we add them. That would give us our answer. So pull out a b, pull out the second b. 72 is like negative 8 and negative 9. Pull out a minus 8 and a minus 9. So I get b minus 8 times b minus 9 times, then a 4b and a 32. 32 is like 4 times 8. So if I pull out a 4, I get 4 times b minus 8. The bottom is a 5b minus 15. 15 is 3 times 5, so I can pull out a 5. I'd be left with b minus 3. So b minus 8's cancel, 5's cancel. On the top I'm left with 4. On the bottom, b minus 9 times b minus 3. Which, if I really wanted to, using the box method again, and I meant to put a 3 down there, I could simplify this And on the bottom instead, get b squared minus 12b plus 27. Either version works. Alright, 22, same thing. So we get an x minus 2 on top. We factor that. And hopefully you've noticed that whatever ends up being the factors here get pulled out here and here. And then this goes here and here. So if you notice that, you can kind of just shortcut it and realize that the factors of negative 16, it would add up to positive 6, which negative 2 and positive 8. So we'd have a minus 2 and a plus 8. So an x minus 2 times an x plus 8, which those could cancel already, times a 7 and a 56. 56 is like 7 times 8. So I'd go 7 pulled out and have x plus 8 left over. Okay, over 2 and 12. Pull out a 2 and I have x plus 6 left over. So x plus 8's cancel. We're left with 7 on top. And then this one on the bottom, which I can leave like that or write like this. Doesn't really matter. Whichever way you want to leave it. Alright, and that's pretty much what we do. So we'll come back to 23. I'm going to skip it for now. So a 2 and a negative 16, we can pull a 2 out because that's like 2 times 8. So 6x over something times 2 pulled out, x minus 8 over x plus 6. And then a 2 and 16 is 8 and 2 again. So pull a 2 out and I'm left with x minus 8 again. So those ones actually, should have noticed they were the same exact thing right there. Duh. You just got 6x over x plus 6. Okay, 29, a 9 and an 18. I can pull a 9 out of that and get p plus 2. And then those 9s would cancel. And I'd have a p plus 2 over 1 times 30p squared over, and we factor that one. Like I said, just whatever factors of the last one that add up to the middle one end up being the information. So I could just go factors of 4 that add up to 4 are going to be positive 2's. So I can skip kind of that whole box method and just go down to here. Cancel a p minus 2, and I'm left with 30p squared over p plus 2. Can't do anything else with it. Okay, number 26. 10b squared, 10 and a b, negative 80b, negative 1 times 8 times 10 times b. So a 10 and a b can get pulled out. So that would become 10b times, and a b is left over, and a negative 8 is left over. Over 20 and 20b, hopefully you can see that I can pull a 20b out, and this side would be left with 1b, and this would be left with a 1, a plus 1. We can't eliminate it. It's got to have that plus 1. Times 18 and 18, well I can pull an 18 out and have b plus 1 over 9. So 20 is like 10 times 2. So the 10s would cancel, the b would cancel, b plus 1s would cancel. 18 is like 2 times 9, so 9s. So I'm left with a 2 times b minus 8 over, no, there's another 2, isn't there? So the 2's can even cancel out. So b minus 8 over 1, which is just b minus 8. Okay. So then 23, an n plus 4 on the bottom. Factor that out. It's kind of like that one. The only difference is they're negative, so it's n minus 2 times n minus 2. This one, pull out a 6 and an n. So I'm left with an n here minus a 10 there. And then this one, you're going to pull out a negative 1 first. And then that would give you a positive n squared plus 2n minus 8. Which then we'd factors of 8 that would add up to 2. 2 and 4, with the 2 being negative. So n minus 2, n plus 4. n plus 4's cancel. 1n minus 2 cancels with that one. This stays the same because I can't really get rid of anything, but we add the negative. So negative 6n times n minus 10 over n minus 2. And we will call that good. Alright, now the last 4 are all division problems. So, and I'm running out of time, trying to keep this under a half hour, so I'm going to go kind of quick on some of these. So, 5x and 25, we can pull out a 5, x plus 1 over 5 times x minus 5 times, then this goes on top, whatever we factor it to, and we get x. Factors of negative 40, that would be a 3, 8 and 5, with 8 positive and 5 negative. Pull out a 10x, we'd be left with x plus 8. So x minus 5's cancel, x plus 8's cancel. Nothing else, so we get x plus 1 over 5 times 10 would be 50x. Okay, 28. Notice these ones look very similar. So if I pulled out just an x, I would have the same thing, wouldn't I? I'd have 70x minus 90. So I'm going to cancel those and just have 1 over x. Times, then this one, we could pull out a few different things. So 6x squared would be like 2 times 3, and then 2 x's. Negative 2x cubed would be like, and I think we want to pull out a negative here too. So if I pulled out a negative 2x squared, I would have a 3, a negative 3 plus x, which is the opposite of that. So those would cancel. And this x would cancel out 1x, so I'm left with negative 2x as my answer. Kind of a crazy one. Okay, 29 and 30. So pull out a 42. We get 42 times m plus 1. 63 times m plus 1. Flip these. Pull out a 6 on the bottom. 6 times m minus 10. And if we pull out a 9, we get 9 times m plus 5. So m plus 1s would cancel. 63 is 77 times 9. 42 is 7 times 6. 7s cancel. 6s cancel. 9s cancel. M plus 5 over m minus 10. Last one, and we're almost out of time. So I pull out a 5. So I get 5n times 7n minus 1 over, pull out a 5 and an n, and we'd have 7n plus 2 times, this goes on top, pull out a 10, and we get 7n plus 2. This one goes on the bottom, and we would pull out a 2, and we get 7n plus 2n, 7n minus 1. Those cancel, those cancel, those two cancel. 10 divided by 2n, well, that would be like 2 times 5. So we'd have 5 on top and on the bottom. There's our answer, and there we are.